Hi everyone, I am Prachi Agarwal from Pranveer Singh Institute of Technology. Welcome to our channel Learn Competitive Programming with CodeChef. If you are interested in competitive programming and want to learn and master data structures and algorithms, then this is a one-stop destination for you. Every week, we'll post CodeChef problem explanations, conceptual videos on various programming patterns, and also conduct live problem-solving sessions. But before we actually get started, here's a reminder to hit the subscribe button if you haven't yet already. Great! Now that you have subscribed, let's get started. So guys, today we'll be discussing the problem coronavirus spread to, which is an easy problem and it belongs to the September Long challenge. Now let us see the agenda for today. First, we will try to understand the problem statement. Then, we will discuss the formulae pertaining to the calculation of time and distance related to the problem. Then, we will see some observations and we'll understand how we can approach this problem. Then, we will discuss the steps involved in solving the problem. And finally, we will implement this problem by discussing the pseudocode, and we will also do a walkthrough of the code, which I'll be coding in Python. So now let us go on to discussing the problem statement. The problem statement says that there is a race where n athletes are participating. Now the initial position of each athlete is known to us. That is, for ith athlete, the initial position, the starting position of the athlete will be I. That is, if we consider athlete 0, then his starting position will be 0. If it is athlete 4, then the starting position will be 4. And also we have the speed of each of the athletes, which is represented by V of I. So we have two things with us, the initial position of the athlete and the velocity or the speed of the athlete. Now it is said that at time equals to 0, that is at the starting of the race, one of the athletes is infected with a virus. Now this one athlete that is infected initially can spread this virus to other athletes. And how can he exactly spread the virus? One athlete can infect another athlete whenever the position and the time are same. That is, whenever two athletes are at the same position and at the same time, then they can infect each other. That is, the initial athlete will be able to infect another athlete. But it is like a chain. A newly infected athlete may then infect others as well. That means first time initially an athlete will be infected and he will infect other athletes. Now when other athletes are infected, they can in turn infect many other athletes. So it goes on like a chain and more people are infected with the virus. Now we do not know which athlete is infected initially. We are not known about that. So we need to find out the best and the worst possible case scenario, that is the number of people that will be infected in the best scenario and in the worst scenario. That is the minimum number of people that can be infected. Best means the minimum number of people that will be infected, and the maximum. Worst means the maximum possible number of people that will be infected because of the first initially infected athlete. That is what we need to find out in the question. Now, let us just quickly see the constraints also, because they are important in understanding the question. So, the input is just the test cases. First line of input, that is for each test case, we will input n, that is the number of athletes, and we will be given the velocity of each athlete. And the positions we already know, that is for athlete 0, the position will be 0. For 1, it will be 1. So that we already know. Then the output for each test case, print a single line containing two space separated integers, the smallest and the largest final number of infected people. So that is what we need to find, the best and the worst possible case scenario. Now let us come to the constraints, which is the most important part of this problem. The constraints are that we are given only maximum of 5 athletes in this problem. So the minimum number of athletes will be 3 and maximum will be 5, which is a very small number. And the velocities are also very small, from the range of 0 to 5. So since the number of athletes that we'll have in this problem as the test case are very small. So what we can do, we can use simply a brute force application here. Brute force means that we will check for each athlete. We will infect each athlete at the starting and then check how many number of people he can infect in future. And then from that we can find out the maximum and minimum. So let us see how we can do that. Okay, now imagine a race, and in the race we have 5 athletes. So I have taken athletes from 0 to 4. Then these are the velocities of the athletes. That is, for athlete 0, the velocity is 4. For athlete 1, the velocity is 3. For athlete 2, the velocity or speed is 5. For athlete 3, it is 1. And for athlete 4, it is 2. And about the positions, so that we already know that the ith athlete will start from the ith position. So that means athlete 0 is starting from position 0, athlete 1 is starting from position 1, athlete 2 from position 2, and so on. So all this we already know. Now the main thing to notice is that this is an infinite race, so we are not given any end point of a race. So we can say that if we try to find out that when two athletes are going to intersect, so then they will intersect at some point of time. But how are we going to decide that for which two athletes we can say that they will always intersect at some point of time? So for that, let us see some formulae first. Now for each athlete, we can say that the equation of their position at any time t is going to be I plus vi into t. So you already know that the formula for distance is speed into time. So that is v of I into t, and plus I. Why have we done this plus I here? Because we have the initial positions of each athlete. So it is not like that all the athletes are starting from the same position, that is 0. No, athlete I is starting from the ith position. That is why in the position at time t, we need to add this factor I. So if we take two athletes, suppose the ith athlete and the jth athlete. So the equation for their distance at any time t is going to be I plus v of I into t, and for the jth athlete will be j plus v of j into t. Now if we need to find the time of their intersection, so these are the positions, and now we need to find the time when they will intersect, and also we need to find out the same position. That means we need to keep the distance also same and the time also same. So if we just equate these two equations for any two athletes, that is for ith and jth athlete, what we'll do, we'll equate these two equations. If we equate these equations, then we are making the position same for the ith athlete and the jth athlete. So let's do that. I plus v of I into t equals to j plus v of j into t. Now from this equation, if we calculate the common factor t, that is the time of their intersection, then we can find out the distance and the position and the time at which two athletes will intersect. So the equation will come out to be this, j minus I divided by v of I minus v of j. So this will be the time of intersection of two athletes I and j, and the position at which they will intersect can be taken from any of these two equations. Both will give us the same answer. Now one more thing that we can derive from this equation is, so this is time, right? And it can never be negative. So what we can say, that I should always be less than j because it is j minus I, and if I will become greater than j, then time will become negative. So what we can say from this equation, that I must be less than j and v of I must be greater than v of j. Only then our athletes will intersect. So it means that if the position of athlete I is less than athlete j, and the velocity of athlete I is greater than velocity of athlete J. Only then in that case they will intersect. And also this is true that if the starting point of one athlete is lesser and the other athlete has a starting point which is greater than the first athlete, but the velocity of the athlete which had a lesser starting point is greater than the second athlete, then at some point of time they will definitely meet. And this is an infinite race. We do not have any ending point to this race. So that is why we can say that they will definitely intersect at some position at some time. Now coming back to our example, and based on our observation that we just found out that I must be less than j and v of I must be greater than v of j for any two athletes to intersect. So what we can do, we can find out the tuple of t comma x for each athlete, for each pair of athletes. What is this t comma x? So t comma x is the time and distance at which any two athletes are intersecting. So like what can we, how can we calculate the time? So for time we had this equation j minus I on v of I minus v of j. Now it makes no sense to calculate the t comma x tuple for 0 comma 0 for the same athlete. So then we will move on to 0 1, and also we need to keep a check of this condition I must be less than j. So definitely our pair of athletes that for which we will calculate t comma x will be 0 1 0 2 0 3 0 4. Then moving on to the first athlete, it will be 1 2 1 3 1 4, because 1 0 it will not qualify this scenario I less than j. So this scenario will not be satisfied if we calculate for 1 comma 0, and for 0 comma 1 we would have already calculated, so we need not calculate for 1 comma 0 again. Now let's see. First we'll check I is less than j. So if I is 0 and j is 1, so 0 is less than j, true. Now let us check their velocity. So the velocity of athlete 0 is 4 and the velocity of athlete 1 is 3, which so the velocity of athlete 0 is greater than velocity of athlete 1. So this condition is also true. So we can calculate the time and distance for these two pairs because they will definitely intersect. Let's put in the value. So j is 1, I is 0, and the velocity of v of I, that is the velocity is 4 for athlete 0 and the velocity is 3 for athlete 1. So it will come out to be 1. The time will come out to be 1. Now we will calculate the distance at which they will intersect. So the distance can be calculated with this formula I plus v of I into t. So what is I? Here I is 0 and v of I is the velocity of athlete 0 is 4 and the time is 1. So the time comma x, that is the time comma distance tuple will be 1 comma 4. So we can say that athlete 0 and athlete 1 will intersect at time t equals to 1 and at position x equals to 4. Now these values can also be decimals because this is a continuous race and these people can intersect at any point of time. So if we calculate like this only, taking these formulae, if we calculate for each pair of athletes, then what we'll get is, so this is the scenario of time and distance pairs that we will get for each pair of athletes. Why for athlete 0 2 it is a blank here? Because the velocity of athlete 0 is not greater than velocity of athlete 2. So velocity of athlete 0 is 4, but velocity of athlete 2 is 5. Velocity of athlete 0 is less than velocity of athlete 2. So that is why this condition had become false, and if this condition becomes false, any of these conditions become false, that is I less than j and v of I greater than j, then these two athletes will never intersect. So that is why on places where you can see this blank, it means that these two pair of athletes will not intersect. Now, why do we need to find out the time and distance of intersection of each pair of athletes? So if you remember that I told you in the starting of the problem that initially one athlete will be infected and he will infect other athletes at the same time in the same position. Now these newly infected athletes can also infect other athletes. But when will they do so? So suppose consider an example. There are three people A, B and C. Now A is initially infected with the virus. So A meets B. So A will transfer the virus to B and A and B meet at a time t1. Now B meets C and since B was infected because of A, now B will transfer the virus to C. So B has transferred the virus to C and B and C meet at a time t2. Now what we can say that B can only transfer the virus to C if t2 is greater than t1. That means their time of meet, the time of meet of B and C should be greater than the time of meet of A and B. Only then it will be able to infect C. So the same thing applies here. Look at this table that we have created of time and distance for each pair of athletes in which they will intersect. Suppose initially we take that athlete 2 is infected. So we are taking initially athlete 2 to be infected with the virus. And we can clearly see from this table that athlete 2 is infecting 3 and 4. So athlete 2 can directly infect athlete 3 and 4. The meeting time of athlete 2 and 3 is 0.25 and the distance is 3.25. Okay. And the meeting time of athlete 2 and 4 is 0.66 and the position is 5.33. Now what we need to check that if athlete 3 or athlete 4 can infect some other athletes or not. So let us check. We'll go to athlete 3. So if you check from here, then athlete 3 is infecting nobody. But if you check column wise, then athlete 3 is infecting 0, 1 and 2. So 2 is already infected. Then we will not check for 2, but we will check for 0 and 1. Now what will be the condition that qualifies to say that 3 will infect 0 and 1 after it is infected by 2? 3 can only infect 0 and 1 if their time is greater than when 3 and 2 met. So the time for athlete 0 and 3 to meet is 1.0 and the position is 4. So it is greater than the meeting time of 2 and 3. So we can say that athlete 3 will infect both 0 and 1. Now we'll go to athlete 4 and we'll check if athlete 4 can infect anybody or not. But since you can see in this tree that already all the athletes have been infected 0, 1, 2, 3 and 4. There were only 5 athletes and all these 5 athletes have been already infected. So we will get our answer as 5. That means if initially athlete 2 is infected, then at last we will get our answer as 5, means it can infect all 5 athletes. So what did we do here? That we needed to calculate the infected athletes in increasing order of time. So instead of writing the time and distance matrix like this, what we can simply do is that we can create a map or with key and value pairs. Okay, so first let us understand what have we taken as our key and value. So in a map, we have taken key as the time and position, and the values will be all the athletes that will intersect at that particular time and position. So I have just copied the values from this matrix to this table, that is the map of key and value pair. I'll tell you for example that suppose consider this time 1.0 and distance 4.0. So this will become our key because this is one of the time and position at which the athletes will intersect. So we have taken this as the key. Now, which are the athletes intersecting at this time and distance, that is time equals to 1 and distance equals to 4. So it is athletes 0 and 1. So we have written 0 and 1 here. Then it is athletes 0 and 3. So we have written 0 and 3. We have added the value, in the value we have added 0 and 3. Then it is 1 and 3. So in the value we have added 1 and 3. So these are all the athletes that will intersect at time equals to 1 and position equals to 4. So they can be, so like you can see that here there is a scenario where at a particular time and position, more than one pair of athletes are intersecting. Now there can also be a case when the time is same for two pair of intersecting athletes, but the distance is different. So then the key will change because for a key to be same, the time and distance, that is the time and position, both should be same. Then only we can say that an athlete is intersecting at that particular time and position. Now, what is the advantage of creating this map is that in this map, what I have done, I have sorted the keys according to the time, according to increasing order of time. As you can see, the first set of time and distance is 0.25. Then after that, the time which is next highest to 0.25 is 0.66, then 1, then 2, then 3. So this key value pair that I am taking is according to the increasing order of time. And that is only the thing that we need to calculate, that which athlete can infect other athletes in a chain. That is, the initial infected athlete will infect some athletes, then those newly infected athletes can also infect some other athletes in turn. So it will be very easy for us to check that if we use a map. And we can also say that if one athlete is infected at time t comma x, then all other athletes at time t comma x will also be infected. So that means that suppose at time t equals to 1 and 4 and position equals to 4, if athlete 0 is infected, suppose, then all other athletes, that is 1 and 3, will also be infected. So that will always be true, definitely, because these are the intersecting athletes at time and position. So now let's quickly take an example. Let's say that initially athlete 3 was infected. So we'll say true for athlete 3. Now we will check each of the map values here. We'll check at key 0.25 comma 3.25, that is t comma x. Is 3 present here? So yes, in the intersecting athletes 3 is present here. That means 2 will also be infected because in this array 3 was already infected, that is, it was true. So because of 3, 2 will also be infected. So we will write true for 2 also. Now we will check in the second pair, and remember that these pairs we have already sorted according to the increasing order of time. So we don't need to worry about that at all. Now we'll check if any of the athletes present here, that is 2 or 4, if they are infected. So yes, 2 is infected here. So because of 2, 4 will also be infected. So we will write true for 4 also. Now we will check the third pair. Now in this, is there any athlete that is infected? So yes, as you can see that here athlete 3 is already infected. So because of athlete 3, athlete 0 and 1 will also be infected. So we'll write true for athletes 0 and 1 also. So now as you can see that because it was increasing order of time, so we didn't need to worry about checking that at a later stage if if any athlete can be infected or not. Like I told you in the previous example, that if A infects B and then B infects C, then the time between B and C should be greater than time between A and C. So that problem is already solved here, because we have taken these pairs in increasing order of time. And now after doing this, in this array, the number of true that we get is the count of all the athletes that will be infected at last. So here it is 5. That means if 3 is initially infected, then all 5 athletes can be infected. So in this manner only, we will find out the number of infected athletes for all the athletes by taking each one to be infected initially. That is, we'll take athlete 0 to be infected initially, then we will check for athlete 1 to be infected initially, and so on. So that is how we are going to approach the problem. Now let us quickly summarize the steps involved in solving the problem. So first, we will need to iterate over each pair of athletes and check that if I is less than j and v of I is greater than v of j, that is, the speed of athlete I is greater than speed of athlete j, and the position of athlete I must be less than position of athlete j, then they will intersect. They will definitely intersect, and they will intersect at time equals to j minus I divided by v of I minus v of j. This is the equation that we derive. And also we know that we can calculate the position also. So we will calculate this for each pair of athletes. Then we will make a map that contains this time and position as the key, and all the intersecting athletes at that particular time and position as the value. And then we will sort this map, like we need to sort this map according to the increasing order of time. Then at last, what we'll do, that for each athlete initially infected, that is one by one we will check for each athlete. We are using brute force here, so we'll check for each athlete one by one. We'll make it initially infected and then check the map in increasing order of time, that if at position t comma x any one athlete is infected, then all other athletes at that position and time will also be infected. And that is how we'll reach our final answer. We will calculate this count for each of the athletes, make them initially infected and then count, and after that we will at last get the minimum and maximum number of people that are getting infected. So now let us discuss the pseudocode. We have already understood the approach, now we will implement it. First, we'll discuss the variables that we'll use in our pseudocode. So the best and worst variable, they will count the minimum and maximum number of people that will get infected respectively, and n is the number of athletes. Then v is an array of size n, which will consist of the speed of the athletes. Then mp, it is a map, and which contains the key as time and position pair, and the value as the athletes which will intersect at a particular time and position at that key. So this is a map and it is named as mp. Now we have this variable in this array as infected, which is also of size n, and this we will take for each athlete. It is a boolean array which will tell us that at any point of time if an athlete is infected or not. Then the count variable. So the count variable, it, as the name suggests, it counts the number of athletes infected for each initially infected athlete. So now let us move on to the pseudocode and see. So first we'll initially take best equals to n, because best stores the minimum number of athletes that can get infected. So we'll take it to be maximum, that is n, that is the number of athletes that we have, and worst will be 0 because it stores the maximum number of athletes that can get infected. Now this part of the pseudocode. First part is this part. What it is doing, it is calculating that at a particular time and position, which athletes are intersecting. So for that, we needed to follow this condition, I less than j and v of I greater than j, v of I greater than v of j. So that is exactly what it is doing. It is running, the outer loop is from 0 to n. That is, consider it like this, that for first time, for athlete 0, we will check that it can intersect with which other athletes. That is, the pair that will be formed will be 0, 1, 0, 2, 0, 3, 0, 4. So that is why the second loop we are taking from I plus 1 to n. We will always get this condition to be true like this. We don't need to check this explicitly. Then we'll only need to check this condition, that is, velocity of the ith athlete must be greater than the velocity of the jth athlete. That is what we are checking. And if this condition becomes true, then we will add I comma j. That means we will add this pair of athletes I and j to the map at position x and time t. That will be our key. That means I and j will intersect at time t and position x. Now, after making the map, so here we have created the map. Now, after creating the map, what we need to do, that now we need to check for each athlete. Remember that we were doing the brute force approach here. That is, initially we will infect each athlete and then check that it can infect how many other athletes in turn. So we have run a loop from 0 to n, that is, it is running, we will check for each athlete. So initially, first athlete 0 will be infected, then this entire loop will run. Then athlete 1 will be infected, again this entire loop will run. So that is how we are working here. Then inside this loop, for each athlete, we will take an array known as infected, which is also of size n, and this will be a Boolean array. Now this array, it will tell us that at any point of time which athletes are infected and which is not. So for the infected athlete, we will store their true, and for the non-infected athlete, we will store false. So now we have made infected at I equals to true. It means that we are saying that initially athlete I is infected. Now we need to check that because of athlete I, how many other athletes will be infected. This is what we are checking here. So suppose if I is equals to 0 first time, then infected at 0 will become true, and rest all others will be by default false. Now, as I told you that we need to take the map in increasing order of time. The keys in the map should be arranged in increasing order of time. So that is what this line says, that we need to check for each pair that is stored in the map. So for each key comma value pair, we are taking in sorted map, and the map is sorted according to the time in increasing order of time. Now inside this map, we are taking spread equals to false. Why are we taking this variable spread equals to false? So this is just a temporary variable which will help us define that if any particular athlete at a particular time and position is infected, then all other athletes at that time and position will also be infected. So we will check, suppose we have taken the first pair, t comma x, that is the first pair in the map. Then its value we will check for each value at map t comma x. We will check if infected at that value is equals to true. That is, suppose at t comma x the values stored are 0 comma 1. So we will check for 0 and we will check for 1 if infected at 0 is true or if infected at 1 is true. And if any one of them is true, then we will make spread equals to true. And now what we need to do, that if we have found that any one athlete is infected, then we know that all other athletes at this time and position will also be infected. So we need to make 0 is already true, so we need to make 1 also true. So that is why we will check that if spread has become true, that is one athlete was infected, then we will enter this if condition, and again we will run a loop for each value at map t comma x, and then we will make each athlete at that time and position as true. So infected at value equals to true. Zero will infected at 0 will also become true, and infected at 1 will also become true. Now this step will be repeated for all the pair of maps that are for all the pairs that are stored in the map. That means for each time and position we will repeat this step. Now after we have repeated this step for each time and position pair that is stored in the map, we will come out of this loop and we will take count equals to 0, because now it is the time to count how many infected athletes have we got, because of initially infected athlete, that was I. So we will run a loop. So preferably you can take this variable as j, because I we have already used in the outer loop. So here you can take the variable as j. So we will run a loop from j equals to 0 to n, that is for each athlete. Again we need to check in the infected array, and if at any position infected at j, if it is true, then we will increment count by 1, because that means that that particular athlete is infected, and if it is false, then we need not do anything. And so this way we will get the number of people, number of athletes that can be infected because of athlete I. Now at last, what we just need to do, that each time we will calculate the minimum, that is out of best and count. So we will get our minimum number of athletes that can be infected, and for worst we will calculate the maximum out of the previous worst and the present count. So this way, at last, that means after we come out of this loop, after all the calculations are done, we will get our minimum number of athletes that can be infected and the maximum number of athletes that can be infected. That is the best and worst possible scenario. So guys, this is our pseudocode, and you don't need to worry much about the time complexity, because we just have maximum 5 athletes that can be given to us. So it is not a very huge number, although the time complexity here will be order of n square, order of n cube. So the time complexity, you don't need to worry much about that. Now let us go on to discussing the code, and then we will also submit it on the CodeChef IDE. So guys, today I'll be coding in Python, and this is just the input, that is for the number of test cases, for the number of athletes, and the velocity or the speed of all the athletes. Then we have initially taken best equals to n and worst equals to 0. This I have already explained in the pseudocode. Now we are defining a map. So in Python we have dictionary. I am taking default dict, that is a default dictionary, so that we do not have a problem that if the key is not present in the dictionary, then it will give an error. So that is why we are taking default dict, so that if any key is not present, then it will automatically create that key. But in C++, what you can do, you can take a map, and the key can be a pair, and the value can be a vector. So that way you can do in C++. And similarly for Java, you can use collections there. There is a map, and there is an array list is also available. So you can use those kinds of collections in Java. Now we will run a loop. So this is the part where we are calculating, we are creating the map in this part, that is at time t and position x, which are the athletes that are going to intersect. So that is the part that we are calculating here. And after we calculate the time and the position for each pair, what we'll do, we'll just need to add this I and j, athlete I and athlete j, we'll need to add it to the map at that time and position as the key. So we have here in Python, we have this append function that we use if we are adding anything at the last of the list. So in C++, there is, I think, push back. So you can use that. Now, we are running a loop. This loop, why are we running? This is the part where we are initially infecting a particular athlete and then checking how many other athletes can it infect. So here we are running a loop from 0 to n. Now we have created a Boolean array infected. So in Python, we don't need to declare the type of the variable explicitly. So that is why I have not declared it here, but infected is a Boolean variable. And initially we have stored false for all values present in infected. Now we will make infected at I equals to true. That means suppose I is 0, then initially athlete 0 is infected, and now we need to check how many other athletes it will infect. Then we have taken another for loop, and here what we have done, we have sorted the map, we have sorted the keys present in the map according to the time. So this function that you see, key equals to lambda x, such that x of 0. So in x of 0, that means the key that is stored here, t comma x, x of 0 denotes the time. So this sorting in the map is done according to the increasing order of time, and we'll get a sorted map that way. Then we have taken a temporary variable spread equals to false, and we will check for each element present at a particular time and position t comma x. We will check for each value that if that particular athlete is infected or not. That is for element in MP of P. So what does this mean? That at map, at position, at key P. Here we have taken for P in sorted keys. So P is denoting each key that is present in the map, and MP of P will give us the values that are stored in the map. So this variable EL, it will contain the athletes that are intersecting at t comma x. All we need to do is that if spread is true after checking for each athlete, then we will make each athlete in infected also true, because that means that if one athlete is infected at time t and position x, then all other athletes will also be infected. So we have made it true. Now we just need to count. So this part of the program just counts from the infected array how many athletes are infected, how many true have we got, and then it just calculates the minimum and the maximum, the present minimum and the present maximum. So that is how we get our best and worst possible case scenario of the number of infected athletes that we will get at the end of the race. And then we will just print the best and the worst. So in Python, this comma will ensure that we have a space in between best and worst. But in other languages, you'll need to take care of this explicitly. You'll need to add a space. And then you may also need to add a new line character in some of the languages. But in Python, it is not necessary. So I have not done that. So guys, this is the code. Now let us submit it and check if it is giving the correct answer to us. Great guys, we have got an accepted answer. If you enjoyed the video, then please like and subscribe to our channel, and also press the bell icon for the upcoming updates. If you have any suggestions or feedback, then you can post it in the comment section below.